All right, so now that we have sort of dusted off some of the rust with our math and revisited some of those important math concepts that we're going to be using not just in our fire investigations, but then also in the next couple of weeks, specifically with our chemistry and physics sections. Let's take a look now at some theoretical aspects of our course, and we'll define a few terms initially, and then we'll again try to relate all this to the ultimate goal, which is how they are related to fire investigation. So our course is physical science for fire investigations or fire investigators, and that means we're going to be studying science. So what exactly is science and where does everything else kind of fit into that? And why is it important that we do know what science is, why we need to study science when we investigate a fire, for instance. So we talk about science, we can say generally that this is just a process of just trying to know about the natural world around us. So the process of knowing uh, about the natural world, but we'll just say the universe around us. And how this is done, how this process is done, is through observations. So things that you see, things that you hear, things that you can measure, all of these things you're going to be using in your investigations. Goes through observations and also experiments. And these are key parts to what science is because it is rooted in making good and thorough observations, and it's rooted in performing experiments. I will talk about how these kind of play into each other when we look at the logical sort of step-by-step way in which we do find out about the world around us. So in your particular field that you're going into, really the world that you're studying there is a fire scene, for example, and you are going to apply some of what we're going to be learning here to decide, well, this is probably most likely what led to this fire. This is how the fire spread, etc. Right? So a lot of that sort of those specific things you're going to see in other classes down the road. Right now, we're just trying to establish the foundation for why we need some of these things. So science, a process of knowing about the natural world of the universe around us through observation and experiment. So under the umbrella of science, there are many different branches of science. There's one main branch called physical science. And what exactly is physical science itself? And we're going to see the difference here and how the two things we're going to study, physics and chemistry, how they kind of tie into physical science. And when we talk about physical science, again, the branch of science itself, this is the study of the inorganic world around us. So in other words, it does not living things. That would be biological or life sciences. What that branch of science is. Now we're going to tie in some of those things, little snippets here and there as we talk about physical science. But again, strictly, this is just a study of the inorganic world, the non-living world around us. And there are several branches of physical science itself. So we're going to see things like astronomy. We might see earth sciences, geology, for example. And the two that we're going to be concerned with these branches of physics, and then we're also going to take a look at chemistry, and we're going to see how they are applied to fire investigation. Right, so we have under physical science, astronomy, earth sciences, physics, and again, as a as a disclaimer, I am a chemist by training, so that's kind of my thing. Um, so I'm going to lean heavily on that. And there's a lot of chemistry involved in fire investigations. So we'll try to draw those connections. We're also going to see some physics as well. So physics and chemistry are parts of physical science. Physical science itself is a branch of science generally. What's physics? What's chemistry? Well, you probably know a little bit about these already. When we talk about physics, what we're looking at here is the science that deals with structure of matter. So we'll go over matter is here in a second, and also the input. Mm, and these are going to be some fairly long words, but we'll break it down in the fundamental constituents of the observable universe, right? Which again, observable universe means the world around us, things that we see on a regular basis. In a non-technical way, on a broad sense, we can say like physics is concerned with all the aspects of the natural world around us, both on the macroscopic, so the large levels of things you can see with your eyes, like a leaf or water, for example, and then also on the submicroscopic level as well, things that you only need a very powerful microscope to see, the proton, neutrons, the atoms, etc. So there's a lot of overlap here between what physics is and what chemistry is as well. You can define chemistry as the study of matter, the changes that matter undergoes, and the energy associated with those changes. Okay, so chemistry, again, both chemistry and physics involve the study of matter, with a common thread for both of these. And then interactions between matter itself, that's also what we see in chemistry as well. And then the changes, that's the key thing about chemistry, looking at changes that matter undergoes, and any energy that accompanies those changes as well. So like I said, there is some overlap between these two, and what's common in both of these definitions here is this idea of matter. So what exactly is matter? So matter is simply, we can think of, again, a non-technical way, the stuff of the universe. Okay, and we can define it more technically as saying matter is anything that has mass and takes up space. Okay, so if you think about it, that is everything around us and everything in us as well. So for example, an example of matter would be something like the pen that I'm using to write with, the water that is in a glass, maybe the glass itself, maybe a water bottle, maybe the pencil. If you just don't want to use a pen, and then what do you write with? Like what exactly makes the mark on the pencil? Well, it's not lead. It's actually the graphite that's in the pencil. And even when you take a deep breath, the air that you're breathing in, right, that is considered, well, that is matter as well. That takes up space, obviously, and you can actually measure the mass of air, sample of air if you wanted to. Okay, so all of these would be examples of matter. Again, the stuff of the universe, anything that has mass and takes up space. And we're going to study a lot about matter and chemistry and physics, and we're going to see how that is going to be related to what you are getting into, which is your fire investigation. Because guess what? in a fire, you have something that catches on fire. That thing that catches on fire, the fuel itself, that is an example of matter, whether it's a piece of wood, whether it's some gasoline, whether it's a piece of paper, right? Whether it's an electrical cord, that is matter. And how that changes, how it undergoes changes, the energy associated with those changes as well. So when the fuel burns, right, how does the temperature change? How does the fire spread? Right, all of those really go all the way back to the study of science, and understanding how that happens is key in your fire investigations.